Hi everyone, in this video we are going to talk about the distance formula in coordinate geometry. This formula is used to find the distance between two given points. Now suppose in this picture right here you can see that I have a Cartesian coordinate plane and there I have 2 points, point P and Q. The location of P is x sub 1 comma y sub 1. Location of Q is x sub 2 comma y sub 2, and we have to find out a formula to calculate the distance between P and Q. And P and Q don't necessarily have to be in the first quadrant, they could be in any quadrant. P could be in third quadrant, second quadrant, even fourth quadrant. Q also can be in any other quadrant. I mean, they can be anywhere, doesn't really matter. We're going to find a general solution or general formula to calculate the distance between any 2 points on the Cartesian coordinate plane. Now, if we have to find this distance, I have indicated that with a dotted green line here, the distance between P and Q, which is the shortest straight line distance between P and Q. Now, if we have to find that distance, can we do a construct like this? So from P, I have drawn a parallel line, parallel to the x-axis, and then also from Q, I have drawn a vertical line which is parallel to the y-axis, and this horizontal line and the vertical line, suppose they meet at point R. Now, if you think about it, what would be the location of R? Well, the location of R would be whatever is the x coordinate of Q, R also has the same x coordinate. So we can say, okay, the x coordinate of R is actually x sub 2. And then what is the y coordinate of R? Well, it will be same as the y coordinate of P because they both are at the same height. So that means it will have y sub 1 as the y coordinate, right? If you look at the distance between PR, so now let's write down what is the PR distance between P and R. Well, distance between P and R would be the difference in their x coordinate, because R goes up to x sub 2 units from the origin and P goes up to x sub 1 units from the origin. So what would be the distance between P and R? Well, because P and R, they both are on the same horizontal line, it will be the difference in their x coordinate, right? Because R is at a distance of x sub 2 from the origin and P is at a distance of x sub 1 units from the origin. So the distance between P and R will be x sub 2 minus x sub 1. And then let's think about QR also. What is the distance between Q and R? Well, it will be again the difference in the y coordinate between Q and R, because Q is at y sub 2 distance from the y-axis and R is at y sub 1 distance from the y-axis. So the distance between Q and R would be y sub 2 minus y sub 1. So now we have the distance between PR and RQ or QR. Now, if you look at this dotted triangle, you will realize that this is a 90-degree angle. This is actually a right angle right here. This is a 90-degree angle. Why? Because our Cartesian coordinate plane is actually a rectangular plane, meaning everything is at 90-degree angle. That the two axes that we have, they are also at 90-degree angle. So it is called a rectangular coordinate plane. And here, whenever we draw horizontal and vertical, they will intersect at right angle at 90 degree, right? So the angle PRQ is actually a 90-degree angle. That means the triangle that we are looking at, that is actually a right triangle. If you think about it, this PRQ or PQR, this triangle, it is actually a right triangle. Now, because it is a right triangle, we should be able to use the Pythagorean theorem to calculate the length of the hypotenuse, which is actually the distance between P and Q that we are trying to calculate. So the distance P and Q, the PQ distance is nothing but the hypotenuse of this right triangle. So let's try to calculate that. Let's use the Pythagorean theorem, right? So for this triangle, if we use the Pythagorean theorem, how is it going to look like? Well, it will be like this. It will be PR square plus RQ squared or QR squared. You can say QR squared would be equal to PQ squared, right? And from here we can say, okay, then PQ squared is actually equal to, what is PR? We have found the value of PR. It is x sub 2 minus x sub 1. So we can say PR would be x sub 2 minus x sub 1 whole squared plus what is QR? Well, QR is actually y sub 2 minus y sub 1. So we can say this will be y sub 2 minus y sub 1 whole squared again, right? And from here, if we take square root on both sides, so on the left hand side we will have PQ, and then on the right hand side we are going to be left with x sub 2 minus x sub 1 whole squared plus y sub 2 minus y sub 1 whole squared. So this is the distance between the points P and Q, right? And this is the distance formula. So let me highlight it. Now let's take an example. Suppose we have 2 points like this, point P at 2, 3, and then we have a point Q at 10, 12. So if we assume that the coordinates of P is actually x sub 1, y sub 1, and let's assume the coordinates of Q as x sub 2, y sub 2, and then let's try to put the values in the formula. So it would be x sub 2 minus x sub 1 whole square. So now I'm going to write x sub 2, which is 10, minus x sub 1, which is 2, their whole square, plus y sub 2 minus y sub 1 whole square. So what is y sub 2? That is 12, and minus y sub 1 is actually 3, so their whole square, and that will be equal to square root of, so this is 8 squared, which is 64, eventually it will be 64, plus 12 minus 3, that is 9 squared, so that would be 9 squared like this, and from here we can say, okay, this is nothing but 8 squared is actually 64, plus 9 squared would be 81, and that will be equal to square root of 145. And you can simplify this, whatever value comes to, that will be the distance between P and Q for this particular example. Now if you take another example, let's suppose in the second example we have P at, let's say, -2, -3, and then we have Q at 2, 3, and we need to find the distance between them. So from here we can say that PQ will be square root of x sub 2 minus x sub 1. So in this case, what is x sub 2? Well, that is actually 2, and then minus what is x sub 1? That is actually -2. So you need to write it like this, and whole square of that. So it would be x sub 2 minus x sub 1. Be very careful about these negative signs depending on where the points are, right? Whatever is the coordinate, whether if the coordinate is negative, you want to carry that negative sign, right? And then the square of the difference of the y coordinates. So what is y sub 2? Well, y sub 2 is actually 3, minus what is y sub 1? Y sub 1 is -3, so that would be -3 like this. And then from here we have to solve it. So now let's solve it and see what happens. So this is essentially 2 minus -2, that is actually 2 plus 2, that is 4. So let me first write like 4 squared maybe. Okay, so that is 4 squared, plus 3 minus, sorry, I missed the square sign there. So this will be 3 minus -3, that would be 3 plus 3, that is 6, so that would be 6 squared. So from here we can say this is equal to 4 4 is 16 plus 36, and that will be equal to square root of 52. 52 is actually square root of 13 times 4, or we can say 4 times 13. And then you can say, okay, this can be written as square root of 4 times square root of 13, which will be then equal to 2. Square root of 4 is actually 2, so 2 then square root of 13, so 2 times square root of 13. That is the distance between P and Q for this example. I hope everything made sense. Thank you for watching. See you in the next video.